Hi, we have AP Physics 1 past paper 2025. We are discussing free response question section. In this section, question number 4 carry the 8 point in question. The scenario 1, a swimmer hold a block of mass m at rest in a tank of fresh water with the density rho 1 as shown in a fig 1. The block is released from rest and accelerate upward with the initial acceleration a1. All frictional forces are negligible. In scenario 2, the swimmer holds the same block at rest in a tank of salt water with the density rho 2. Density of the salt water is greater fresh water, rho 2 is greater than rho 1. The swimmer again release the block from rest and block accelerate upward with the initial acceleration a2. All frictional forces are negligible. In this case, only one difference, there is a fresh water, there is a salt water. Now indicate whether a1 is greater than, less than or equal to a2 by writing the following in your answer booklet. A1 is greater than A2, A1 is less than A2, A1 is equal to A2. Justify your answer in terms of all forces exerted on a block in each scenario. Use qualitative reasoning beyond referencing equation. Okay, now the answer is A1 is less than A2, mean acceleration in salt water is greater than acceleration in fresh water, comparing. Weight, now justification. Weight is one of the force that is acting on a block. Weight always act downward since the same block in both scenarios. So the weight exactly same in two cases. Now the main is the beyond force acting upward. According to the Archimedes principle, the beyond force equal to the weight of the fluid displaced. Since the block is completely submerged, the volume displaced fluid equal to the block volume. Volume is same in both scenarios. Its mean volume is a constant factor in both scenarios, but there is a change in density. Now, displaced salt water weigh more than the displaced fresh water. This results the larger upward beyond force in a salt water. Beyond force is proportional to the density of the fluid. So, the density of the salt water is greater than as compared to the density of the fresh water. Since the downward weight remain constant, total net upward force is greater in salt water. According to the second law, greater net force for the same mass result greater acceleration. So in the salt water, there is a larger force, there is a larger acceleration in salt water. Now consider the general case where the block of mass m and the volume v is completely submerged in a fluid of density rho. Starting Newton's second law drives the expression of the initial upward acceleration a of the block when a block is released from the rest. Express your answer in terms of m, v, rho, physical constants appropriate. Bring your derivation by writing the fundamental principle of an equation of reference information. Newton's second law states that the net force acting on an object equal to the mass time acceleration, square root f is equal to the ma. Now there is the two forces. We know one is the weight, one is the buoyancy force. Buoyancy force is acting upward. So upward is taken positive direction, downward is taken negative direction. So rho Vg minus mg, F is equal to the ma. We have to calculate the acceleration and move to the other side. So we have the acceleration rho Vg over m minus g. We can take the g common from both sides. So g is equal to a is equal to g rho v by m is minus 1. So that's the basic acceleration tool for we calculate in this scenario. Now indicate the whether the expression of acceleration you derive in part B is or not consistent with the claim made in part A. Briefly justify your answer by referring your derivation in part B. From the part B, we have the derivation of the tool A is equal to G rho V by M minus 1. Mass, volume and gravitational acceleration is same in both scenarios. Since the density rho 2 is greater than rho 1, acceleration of A depend directly upon fluid density. So therefore, that if row 2 is greater than row 1, then A2 is greater than A1. This matches the qualitative reasoning in a part where the denser salt water produce more acceleration than the fresh water A1. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.